Alright, I'm Steve Clunn with Green Shed Conversions, and today we're going to look at the 48 volt Mini BMS Headboard. Now, our BMS modules look like this, and they connect to the negative and the positive of each cell. And this is a little review. When we hook them, when we daisy chain them together, or we are hooking these spade terminals from one to the other, and then from this spade terminal back to our what is called cell loop. Now what this does is, as long as these guys are happy, as long as the voltage is between 3.65 and 2.7, or it might be 2.5, these guys will conduct between these two terminals. They're like a switch that is switched on. So with everybody in our group switched on, we get a complete circuit, and that basically just makes a complete circuit with our cell loop, which, if we look right here on our test board, I've duplicated with these alligator clips just for testing purposes. Alright, I've also hooked up a little reset button right here, and that's this reset button here. So we've got our cell loop, we got our reset button, which is just a switch, momentary on switch. Next we have our ground wire, which goes to the ground of our 48 volt pack, and we have the B plus, which goes through a switch also, so we can turn this whole thing off when we're not using it, so it doesn't drain our batteries down, and that goes to our B plus. Our next one is our relay plus. Now these two terminals basically hook up to this same B plus here, and they're going to go to the plus of our relays unless we're using some other voltage. But if we've got like a 48 volt main contactor, we got a 48 volt buzzer and a 48 volt low voltage relay, high voltage relay, we're okay with 48 volts. Otherwise, we could set this up to run on 12 also. What we would do there is we would hook our ground from our 12 volt battery to this ground, and we would use this line coming out here, which is the opposite of our it's on the other end of our wire coming here. So we got our this basically supplies a ground, is what it does. When this comes on, we now have a ground, and the current will come from the ground. Well, actually, so that completes our circuit with the plus going to whatever voltage we have. If we've got 48 volts, then we're going to come from here, one of these terminals, either one. And as you can see from my setup here, I've got this coming over here to this one here, and it's coming off this first block. Okay, so right now we've got this lit up, and this is between our E terminal, our very last one, and he would be on the page here. They show him as this main contactor. Of course, you can use him for what you want, just as long as you know what he does. And what he does is he supplies a ground to this terminal when everything is okay to go, which if we had a relay or a contactor, that would mean the contactor would be on as long as everything is good to go. Now the one situation with this, when you're hooking it up, if you're going to hook this up to your main contactor, you might want to have it on a switch so that you could turn it off when you're charging. Or if you have it hooked up to a charging contactor, then you need to know that this has quite a delay from when the first cell hits 3.65 volts to when this shuts off is almost a minute. I'm not exactly sure. We'll time it now and see how long it is. These other two are, one is for a buzzer in their picture, and the other they have for the low voltage cutout or the high voltage cutout. They're both the same, because all this thing is really looking for is a break in this terminal. So high voltage, low voltage, whatever, it does the same thing to the input of this headboard, which is to open this loop here. All right, so I'm going to open this loop kind of like like we'd be driving along and something happened and we pushed their batteries so far that they dropped, one of them dropped below 2.5 volts. And there you see our alarm would come on. And this, we could have this hooked up to a relay that would go across our throttle box to cut back our power. That would be a relay with a little resistor that would go across the resistor that you have for a throttle. As you see though, our main contactor is still on. That's the red light over there, and he stays on for quite a while after the era to give you time to get off the road or to release your. Now, if let's say you take your foot off the gas and let the batteries come up, which will connect these wires again, we see that what we see is we still have an error light, but our main contactor will stay on instead of going off. And if I push this button and hold it down for a second, our error lights go off, and now we can continue driving. Of course, if our batteries are low, they're going to open up again when we give it juice, and if they stay open long enough, that our error lights will come back on. And that was at 22 seconds. So now we're going to wait and see how long it takes for that main contactor to shut off. This is the time it's giving you to get to do something, to get off the road or whatever you got to do. If you let off on the go pedal, you could get another cycle out of it, and try to go home slower. If you're accelerating very quickly, then that will go off on its own when you get up to speed. But you'll still have your error lights on, showing you that, yeah, you did hit that low marker. And if you hit the switch, it'll turn those lights off. But we're waiting now to see how long it takes before there goes the main contactor. So now it shut you down altogether. So I'm going to put these wires back together. And we've got our error light on and our main contactor is off. I push down on the reset switch and hold it. You got to hold it for a second or two, and then we're back driving again with no errors. So there we have the way this thing hooks up. Now, if you're going to use this to control your charger or your main contactor, that's fine. You can do that. I like to use I like to run a relay from these. Now you get your 48 volt relay or whatever, just as long as you're not trying to force a lot of current through these, because they're little parts and I don't think they want to handle over an amp. Alright, now I'm going to talk about relays and the different types there are. There's double pole, double throw is a very common type. That means it's got two on and offs, and the on and offs have on when it's not on and on when it is on. So they have two sets of points, and the little reed that goes in between them we can see here. And as we can see here from the picture, this is not on right now, and it's and we have our light bulb on. Now the way that this works is that we're going to the what is called the normally closed group. There's a normally closed and then there's a normally open. And when they say normally, they mean without power to it. So once I put power to this and the relay engages, now I'm putting power to the coil. And of course I'm whatever rating the coil is, which this coil is a 6-volter. And as you see, the light went out, our reed clicked down, and if we were connected to this bottom one, our light would be on. Our light is on now when we have power. When we turn power off, our light is off. So power to the coil off, power to the light off. If we switch these around, then we get just the opposite. Power to the coil, no light, no power, and we get light. So this is a very convenient way to make things switch off when we put power to it, or switch on when we put power to it. And that's with our with these setups that our outputs are either on for our main contactor or off for our warning lights when everything is happy. Our warning light comes on, that gives power to, if we have a contactor in there, or a buzzer, it gives power to the buzzer, or it gives power to the contactor. And if we use this setup here, we can make it do what we want, which we would want is when this light bulb comes on, or when this is energized, we then want the relay to turn our charger, which I have as a light bulb, off. So that's why we would use those. Or we could also use this right here, but this has that long delay, which you may not like. All right, this is a simple circuit showing how to hook the contactor or relay, to hook it up to do a speed reduction on your controller. As you remember, the two lights that came on first, one was said to be a buzzer or a warning light or whatever you decide. The other can be hooked up to this circuit right here, with which this is our speed control here. And if your controller is set to be 0 to 5K, 5K being full speed, 0 being stopped, by adding this resistor in line, this is like a half speed shutdown. So when you're driving along, your low voltage comes on, this relay comes on, that light comes on like we saw, which is now going to be this relay. And when it comes on, this connects this resistor here in parallel with the variable resistor, which means that our maximum throttle will be half, because it's 2.5K, even if this is all the way open. Of course, if this is all the way shut, if you take your foot off the go pedal, then of course it'll be 0. There'll be no current flowing out of the controller, and your battery's voltage will rise back up again. This is one way of setting that up. I think this is in their brochure somewhere too. Not brochure, but their website.